Okay, so I think that we can start now, and if people keeps joining, they can do it with no problem. So in today's session, we are going to review the latest updates of the last quarter of Q4 of 2023. And before starting, I would like to introduce myself. I'm going to be the speaker for today. My name is Alvaro Pajares. I've been working here at Rated Power for now more than 3 years and a half. I started working with the customer success team, helping our clients to optimize their designs with PV design and supporting them on their journey. Then I've been also working as a software engineer for the product team, not only defining the requirements of some of the new developments, but also developing them. And now I'm working as a product owner also for the product team, for the generation team, where we are also defining the requirements of new developments, new features, and some improvements that we can do with the tool, with PV Design. That being said, and before going through the agenda, I would like to remind you that you can leave any questions in the questions section through the session, and we will have some time at the last time of the presentation to answer all the questions. The idea is that the webinar will take around 20 to 25 minutes, and then we will have time for the questions. So the agenda of today is what we can see in this slide. The first thing that we are going to review is the new capabilities of simulating with sub-hourly energy production. This has been one of the major features that we launched in last quarter. And now, as we will see now, users are able to upload meteorological data with sub-hourly resolution and simulate all the intervals that they upload with the meteorological data. Second, we will review also that we have now improved the way of downloading documentation from the new interface. As you know, in Q2, we modified the new interface so that we had like a design process which was better to iterate and to run more designs and get more information. And now we are also improving that new interface to try to improve the user experience from our users. Then we have also made some improvements on the way that we install partial structures. We will see it now, but we have added more options on the selection of partial structures and also improved the installation of those. Then we have also made a detailed review of the Italian documentation, and we have improved its translation. Then another major feature from last quarter is the slopes direction differentiation. And with this new tool, now our users can differentiate between the structures that are facing north or facing south and put different limits from the topography analysis so that they can have more control over the topographical restrictions. Last but not least, we have also added more information about the overhead lines on the map directly from the design process tab and from the results page. And now we have more information about these overhead lines from there. So first of all, starting with October, as I mentioned, we launched the sub-hourly energy production. With this new feature, now users can upload TMYs of 15, 5, and 1 minute into PV Design, and we will run the simulation with all the intervals that we have uploaded to the software. This way, we will have an enhanced granularity, which will better represent the irradiance fluctuations that may push PV systems into and out of the inverter clipping, which hourly models will mask. Here we notice that the trend of the market was going in a direction where we are hybridizing more PV plants, we are putting more higher DC-AC radios, and we need to have like more granular energy results. And for that reason, we included this possibility in our software. I would like to go now to PV design and briefly show you how can we perform a sub-hourly simulation. The only thing that we are going to need is to upload meteorological data with sub-hourly resolution. We can upload, as I mentioned, 15-minute, 5-minute, and 1-minute meteorological data. And then once we select the file, we will be able to run the design and get all the results with the resolution that we have uploaded. I have taken the energy reports for both simulations with hourly and 1-minute simulation that I have done for this specific design, which was in Washington. And I would like to review with you a bit some differences that we could see when simulating with one resolution or another. So first of all, if we review in detail all the losses that we have in the energy production, one thing that we may notice is that the transposition to the plane of array will give us different values for hourly and sub-hourly data. This is due to the fact that, well, we will see differences in both direct and diffuse components. And this is due to the fact that with 1-minute resolution, we will evaluate the sun position for every instant or for every interval that we are checking, while for hourly data, we take the center of the interval as the reference point for the whole interval, and maybe there are some discrepancies between these two values. Another thing that will normally we can see from the different designs is the fact that, as we will expect, due to these fluctuations here in irradiance, we may get some moments where with hourly data we are masking these irradiance fluctuations and we are not considering the inverter clipping losses correctly. And this can be seen here from the losses due to the inverter output power limit, and how with hourly simulations we are getting around 0.5% more of energy because we are not considering correctly the inverter clipping losses. The last thing to show related to sub-hourly simulations is how we are going to bring our users the information for every interval that we are simulating. And so if we simulate with 1-minute data, for example, we will have for all the minutes within a year and within all the years to see the results of energy production. So we will see here how we have more than 500,000 intervals that have been simulated. This can be seen not only for the energy production, but also for if we want more detailed results, we can see also the sun position, irradiance results, and also the inverters results. So with that being said, I'm gonna go back to the presentation. And also, before going to the following slide, one more thing to highlight here is the picture that we can see here, where if we check the sub-hourly results, we can see how there are some fluctuations due to the irradiance fluctuations in the power at the inverter output for one specific hour in which we had clouds. And however, if we go for the hourly results, we will be not getting any inverter clipping loss, and that's why the hourly simulation may mask or hide these irradiance fluctuations, while with sub-hourly we may get those better. Continuing with the following slide, as I mentioned, in Q2 we made a major improvement of the design process of PV design, where we wanted to give more importance to the design process, have more information, and be able to iterate more and with more information, so that we can make better our iterations. And we are still improving this design process, this new interface. And one thing that we have added is the possibility of downloading directly documentation from the design process. Before this development, we had to go back to the results page and download them from there, and now we can download the documentation directly from this page. Continuing with the following development, we have also improved the partial structures installation in the PV plants. This, as I mentioned, we have done two main improvements here. First of all, we have improved the way that we prioritize structures that are going to be installed. In this case, if we have, due to the electrical constraints, we have some structures that are not going to be installed in the final design. Now we prioritize better the ones that are going to be installed in this final design. This way, we now prioritize the electrical installation of partial structures that are surrounded by already electrically installed structures or adjacent to them. And as we can see in this design, the structures that will be rejected are the ones that are closer to the borders of the available area. Apart from that, we have also increased the possibilities from the drop down that we have when selecting the partial structures that we want to consider for the design. And now we will have all the possible strings per structure visible in the drop down, and up to 5 partial structures can be selected from this drop down. Again, I would like to go to PV design and show you some results. This will be the first improvement, will be showing the first improvement that we did. And here in this case, I have selected partial structures of 2 and 1 strings. And we can see how, as I want specifically a 1.2 as DCAC radio, we are getting that 1.2 of DCAC radio, and how some structures are not installed in order to reach this specific value. By doing that, now we can see how the structures that are rejected are the ones with less strings per structure, but also are the ones that are not adjacent to others or that are in a worse position. Apart from that, the second improvement was the fact that now in the dropdown we have more options, and that is particularly important for thin film modules where we have high voltages, and so we can put less modules in to build one string. So we will have more strings per structure, and we may have more options here to select now, as we will have all the possible options from the drop down, and up to 5 options can be selected from the drop down. Then continuing with the presentation, in November, the main highlight was that we have launched an improved Italian translation. As I mentioned before, we reviewed in detail with more technical knowledge of the Italian translation, all the documents that we provide with PV design, and the documentation related to the PV plant, the battery energy storage system, and the interconnection systems has been reviewed, and the translation of reports, drawings, and sheets has been updated. Here we can see briefly the translations in Italian and how those documents have been adapted in more detail to this language. Then going for December, first we can see the other major improvement or the major feature that I was mentioning before, which is the slopes direction differentiation. And with this new tool, now our users can differentiate between the direction of the slopes when performing the topographic analysis. This way, they can distinguish, discard, or apply earthworks between north and south facing structures in one design, and our users will gain in control over the structures that are going to be removed and be closer to the final design that they would like to get and differentiate between these slopes. Again, I'm gonna go back to PV design and show you some examples that I have prepared. So if I go to the old way that we had to remove structures from the topography analysis tool. We will have the same value for the limits and earthworks for both slopes. So if I want 10% for both directions, we will be defining it this way. And we weren't able to differentiate between north and south slopes. However, if we want to distinguish between these two slopes direction, and we want to put one value for the north and another for the south, for example, if we want to consider the possibility of shades in the north and not in the south, but we want to consider also the installation constraints from the south. We can do that by differentiating north and south facing slopes. So we can put a different value for the north, a different value for the south. And in this case, for example, I have put that I want up to 10% limits in the north facing slopes and up to 15 in the south facing slopes. This way we will be getting much more power in this specific case. And even we could also perform some earthworks in one direction only. And I could say that I want to reject all the structures that are facing south in places with the slopes higher than 25%, but between 15 and 25, we can perform some earthworks. And in these specific designs, we went from a base case where we had the same value for both directions and we were getting 53.6 megawatts DC, to a case in which we were differentiating between those slopes and getting 59.2, to a case where also earthworks were applied and 62 megawatts in DC was reached. Then the last thing that I wanted to highlight here in this presentation is the fact that now we have more information on the map related to overhead lines. And this way we can now visualize the overhead lines final path in the map, which was not possible before. But also we have the position of the towers and information for each one of the towers. And as we can see from this video, we can see now the angle of the towers, the coordinates, the height, the previous span, and the next span of each of the towers. This is visible not only from the design process. If I go to overview, we can see this information, coordinates, height, previous span, and next span, and also the type of tower. But also from the design results where we have the same information. And this was all that I wanted to show you. Before going through the questions, I wanted to also briefly mention that during this quarter, we have put a lot of effort also on improving on the times that simulations take. So we have put a lot of effort on reducing the times of the simulations so that we can iterate more and better from the new design process that we had in PV design. And for that reason, we have spent also a lot of time on reducing times. And you will notice that maybe some simulations will take less time than before, and so we can iterate more and better in the new design process. And that being said, we can now go to the questions. I see that we have a question related to the overhead lines and if it will be added on the layout drawing or to get an option. And the answer is yes, it's in the roadmap. We are working on that and we'll be working during the next year on these options. And yeah, hopefully in the future we'll have also the overhead lines in the layout drawing. I see here another question, which is about what about a grid connection with AA cable? All grid connections 150 kilovolts and lower in my area are required to be with cables. I'm not sure if this is if the question is related to the underground cables, but if that's the case, we will be also working on that. And in the future, for the interconnection system, we want to also allow having underground cables, and we are improving there and trying to get more options for the overhead lines, and hopefully in the future we have that option too. Hello, do you foresee to do any improvement on in-earth movements? By now, I will say that in short term, we are not doing any modifications. We did major improvements during the last year related to the way that we do earthworks and how we perform the platforms, how we group the structures that follow to the same group and things like that. And in the future, we will try to get more editability in general to the layout, to our users, and this could be an option too, to have more editability in the earthworks. But in short term, I'd say that we are not going to apply any improvement, as during the last year we did also some improvements related to these earthworks. And I don't see any additional question. Let's give it one moment. Okay, so if there are no other questions, I think that we can leave it here. Thank you all for joining. In case you have any additional question, maybe that didn't came up during the webinar, you can write me also to my email, apajares@raterpower.com, and I'll be happy to answer. And yeah, thank you very much for joining. I hope it was useful, and thank you very much.